Assalamualaikum and good day everyone. In this video, we will present our road safety audit project conducted at a selected road segment in UiTM Shah Alam. The main objective of this project is to identify potential road safety issues at a vertical curve section through site observation and analysis. We evaluated 5 key parameters, which is alignment, speeding, visual aid, street lighting, and vulnerable road user infrastructure. Based on our findings, we identified the existing safety issues and proposed suitable improvements to enhance road safety for all road users. Now, let's begin with the first parameter.
I will focus on issue of vehicle speed at this location. Based on our observation, many vehicles tend to travel at high speed, especially along this vertical curve section, which may reduce visibility and increase the risk of accidents. To measure vehicle speed more accurately, we use a laser speed gun. This device works by emitting a laser beam towards a moving vehicle and calculating its speed based on the change in distance over time. During the field study, we position ourselves at a safe location and aim the device at approaching vehicles to record their speed readings. All measurements were conducted from a safe distance to ensure the safety of the team during data collection. The speed gun applied the basic principle of velocity, where speed is determined from the change in distance over time. This allows us to obtain real-time and more accurate speed measurements compared to manual methods. Possible solution is the installation of rubber strip, which physically force drivers to slow down before entering the vertical curve. Next, road markings such as slow or directional arrow can further enhance driver awareness and guide their speed behavior.
Next, we identified an issue related to vulnerable road user infrastructure. At this location, there is a bus stop on the opposite side of the road, but there is no proper pedestrians walkway provided. As a result, pedestrians are forced to walk along the roadside and cross the road without a safe designated path. This situation increases the risk of accidents, especially during peak traffic hours when traffic volume is higher. It also makes it difficult for pedestrians, particularly children and elderly, to access the bus stop safely. Since pedestrians are considered vulnerable road users, proper facility should be provided to ensure their safety. Therefore, we propose the construction of pedestrians walkway and a marked pedestrians crossing near the bus stop. This improvement would provide safer access to public transport, improve pedestrian safety, and reduce potential conflict between vehicle and pedestrians.
For this section, we focus on the alignment aspect at our selected road location in Bukit Tonggek, UiTM Shah Alam. Based on our observation, this road has a steep vertical curve or hilly section. Because of the road shape, drivers coming from the lower side cannot clearly see vehicles approaching from the upper side. This limited visibility may reduce driver reaction time because drivers only become aware of other vehicles when they are already close to each other. This condition can increase the risk of sudden braking and may affect road safety. To improve safety at this location, several mitigation measures are suggested. First, warning signs can be installed before the vertical curve to alert drivers. Second, a convex mirror can be placed at the road section to help drivers see approaching vehicles more clearly. Lastly, road markings can be improved to increase driver awareness. These improvements can help drivers react earlier and create a safer driving environment.
Hi everyone, right now we will analyze the issue of poor street lighting at Bukit Tonggek Road. Our observation showed that several street lights were not functioning while some provided insufficient brightness during nighttime. This issue creates poor visibility, especially for drivers, pedestrians, and also cyclists. As a result, drivers may not be able to detect road hazard, pedestrians, or animals in time, which can increase the risk of traffic accidents. Furthermore, poor lighting can also make pedestrians feel unsafe and increase the likelihood of crime in the area. To address this issue, regular inspection and maintenance of all street lights need to be conducted to ensure damaged lights are repaired or replaced immediately. Other than that, upgrading existing lights to LED street lamps is also recommended because they provide brighter illumination, consume less energy, and have a longer lifespan than conventional lighting. In addition, more street lights should be installed in dark sections of the road to eliminate blind spots and ensure uniform lighting coverage. These recommendations are consistent with road safety and highway lighting standards, which emphasize that adequate nighttime visibility is essential for reducing accidents and improving road user safety. In conclusion, improving the street lighting system will enhance visibility, increase driver reaction time, improve pedestrian safety, and create a safer road environment for all users.
At this particular alignment section, the center blocker white lines are completely faded and missing. Driver have no visual lane demarcation. Also, the road surface is damaged and uneven. Missing visual aid and unpaired road surface reduce vehicle stability and lane discipline. We propose to resurface the damaged pavement layer to make it smooth and safe. After repairing the road surface, the center blocker lines must be repainted using high visibility reflective thermoplastic paint. This follows ECG563 standard to provide clear visual guidance for road users. At night, the yellow thermoplastic markings on the speed hump are completely invisible to oncoming drivers. The paint has lost its retroreflectivity due to heavy traffic wear. To fix this issue, the speed hump must be repainted using reflective thermoplastic paint embedded with glass beads to maximize night visibility following ECG563 85 guideline. Next, at this intersection near the bank exclamation bar heart, important road markings like directional arrow are critically faded. The lack of visual guidance making traffic confusing and poor lane discipline. Our mitigation strategy is to repaint all junction road markings, including directional arrow, using high durability reflective thermoplastic road paint. This will restore nighttime visibility, guide drivers safely through the intersection, and meet the safety standard.
This is our data collection using an automatic method with a radar gun. We recorded the speed of 100 vehicles passing through this area. The three key results required from this experiment are: first, the model speed is 52 km per hour, meaning the majority of drivers feel most comfortable driving at this speed. Next, the mean speed of the vehicles here is 53.3 km per hour. And lastly, 85 percentile speed, P85 is 61 km per hour. According to Malaysian JKR standard through the NTJ 34 2016 guideline, the 85 percentile speed is the primary benchmark used by engineers to establish a safe and realistic speed limit for any given road.
In conclusion, our road safety audit identifies several safety issues at the selected location, including limited sight distance, inadequate signage, and insufficient facilities for vulnerable road users. These issues may increase the risk of accidents and reduce the overall safety of the road environment. Based on our findings, we propose practical improvements such as enhancing road signage, improving visibilities, and providing safer pedestrian facilities. Implementing these measures will help reduce potential hazards, improve traffic, and create a safer environment for all road users.